So finally, my lab is working perfectly. I can see now route type 5. So in today's lab, I will show you how to do the configuration so that your devices will generate the route type 5 for your SVIs. Okay. So in our previous section, we have seen the packet flow between two leaf switches, and the end hosts were in two different subnet, and we took the example of silent hosts, right? And we discussed that what is the use of route type 5, or how route type 5 is going to help us to communicate in case of silent hosts, right? So there is very simple configuration. So if I go to leaf 3, so let me go to leaf 3. So if I do a show run interface VLAN 10, okay. Now I wanted to show you that if I go to here, so host 1 is silent, okay. So if I go to leaf 3, so leaf 3, if I check the VRF table, you can see that leaf 3 does not know about 10.1.3, right? There is no information with leaf 3 for 10.1.1.3. But on the other hand, host 6, which is connected to leaf 5, it is not a silent host. So you can see that if I go to leaf 5, it knows about host 6. So you can see that it knows about 20.1.1.5. You can also check the ARP table, show IP R VRF customer A. So leaf 5 knows about the IP address and MAC address of host 6. That is why it generated the BGP EVPN update, EVPN, and then maybe you can say 20.1.1.5, right? It generated a BGP EVPN update using the route type 2. And you can see that it has the /272 because this route type 2 contains the MAC address as well as the IP address. On the labels, you can see we have the L2 VNI corresponding to VLAN 20, and we have the L3 VNI, right? This is the L3 VNI for VRF customer A. Also into the extended community, you can see that we have the route target for L2 VNI, so which is a combination of the BGPS number and the VNI ID for VLAN 20, because we have configured route target as auto. So this we discussed a couple of times. Then we have the RT value for L3 VNI, which is also a combination of the BGPS number plus the L3 VNI ID, right, for VRF customer A. Then we have encapsulation number 8, which is used for VXLAN. And we are receiving the router MAC, which is the router MAC of leaf 5 itself, because this is the self-generated route, right? You can also check it with show NVE interface. You can see that the local router MAC is 1B08. So if I go to leaf 3, now leaf 3 will also be receiving this particular information. You can see that in the VRF table also it knows about 20.1.1.5. It is receiving this particular information from leaf 5 via the BGP EVPN, right? So now you can also check L2 VPN, EVPN, and if you check the route that we received from leaf 5, so 20.1.1.5, you can see that we are receiving this particular information as a route type 2, right? We can see the /272 value for route type 2, which includes MAC address plus the IP address. And now you can see the router MAC, which is the router MAC of leaf 5. So leaf 3 is receiving the information about end host 6, right? this one, because it is not a silent host, but there is no information at leaf 3 or leaf 5 about host 1. You can see if you go to leaf 5, show BGP, L2 VPN, EVPN pipe include 10.1.1.3. No information is there, right? So also on leaf 5, there is no host as of now for in VLAN 10. That is why you can see that VLAN interface VLAN 10 is admin down. Similarly, on leaf 3, show interface VLAN 20 is admin down. Still, you can see that our end hosts, they can communicate. Why? Because let's say if I ping from host 1 to host 6, so host 1 is going to send the payload or the ICMP traffic to leaf 3, right? Now, at leaf 3, it already knows about 20.1.1.5, right? If you go to leaf 3, so show IP route VRF customer A, it already knows about 20.1.1.5, right? So directly it can encapsulate the traffic to 5.5.5. And because it is a routing traffic, as we discussed in our previous packet flow also, that the source, inner source MAC and destination MAC, that will be the router MAC of the source VTAP. So leaf 3 already knows about its router MAC, right? If you do a show VNI interface, show, sorry, NVE interface. So it already knows about its local router MAC, and the remote router MAC, it already received into the BGP EVPN update, right? We already checked if you, this one. So now it can encapsulate the traffic properly to leaf 5. So once leaf 5 received this particular traffic, so if you go to leaf 5, so leaf 5 is going to check its VRF table, but I mean into the VRF table, it knows about 20.1.5, so it can directly send the traffic to 20.1.1.5, right? So when host 6 is going to reply, so leaf 5 will receive the traffic for which 10.1.1.3. But do we have 10.1.1.3 information with leaf 5? If you go to leaf 5, show IP route VRF customer A. So you can see that there is no information related to 10.1.1.3 into the VRF table of leaf 5, but you can see that it knows about a subnet 10.0.0.0/8 via 3.3.3, because leaf 3 advertised a route type 5, okay, for this particular subnet. If you open it, show BGP L2 VPN EVPN 10.0.0.0, you can see that we are receiving this particular subnet as a route type 5. You can see now in the bracket, it is 5. It is a route type 5, right? And route type 5, it will be having the /224 value. And you can see in the received label, it is receiving layer 3 VNI. In the extended community, we have again the RT value, and we are also receiving the router MAC. So now you can see that 0007 is the router MAC of router 3. If you can check here, show NVE interface, you can see that 777 is the router MAC of leaf 3. So now using route type 5, it can, or leaf 5 can route this particular traffic directly to leaf 3, because it already knows about a subnet, right? 10.0.0.0/8, though it does not know about the actual endpoint, but it has a route so that it can send the particular traffic to that particular leaf, or in our example, leaf 3. You can also run a command to check route type 5, show BGP L2 VPN EVPN route type 5. Okay, it will also give you the same information. Or if you do a show BGP L2 VPN EVPN, you can see that we are receiving a route type 5 from router 3 for subnet 10.0.0. Likewise, you can see that Leaf 5 is also advertising a route type 5 for the 20 subnet, right? So you can see, we have already checked, you can see in the VRF table, we have a 10 subnet, but our SVI is shut, right? So this is not something that is generated by the SVI because SVI is shut down. Similarly, the route type 5 for 20 subnet will be received at leaf 3. If you do a show BGP L2 VPN EVPN route type 5, you can see here the route type 5 from leaf 5 is received at leaf 3. Okay, so this is how the two devices can communicate using the route type 5. Though you can see that there now between leaf 3 and leaf 5 there is no broadcast domain, right? They cannot send the bump traffic because there is no VLAN 20 active on leaf 3 and there is no VLAN 10 active at leaf 5. Still they can communicate and they are exchanging the BGP VPN update. So using that routing concept, now they can route the traffic to each other. Now I'll show you the configuration part. It is very, very simple. So what I have done, if you go to show run interface VLAN 10 on leaf 3. So after the IP address, I just put a tag, let's say 1010, and then I created, if I do a show run section BGP, so I created one route map, this show route map. Yeah, I created one simple route map wherein I match the tag 1010. Okay, and then under the BGP configuration, you can see that router BGP. I'll go into the VRF mode, the VRF customer A, and then under the address family IPv4 unicast, I will just say redistribute direct, right? Because the SVI will be a direct route, right? And then I'll call the route map, simple configuration. Okay, so first add the tag after the SVI or the anycast, IP. Okay. Second, then create one route map and match the above tag. Then simple go into the VRF under the BGP, go into the address family unicast, IPv4 unicast, and then redistribute the direct along with the route map that we created. That's it. Okay, there is one more command, but it is not supported in my lab. So after this redistribute command, you can also say advertised L2 VPN EVPN. But in my scenario, I mean, in this particular lab environment, it is not working. Maybe on the real devices, that particular command will work. It is just advertised L2 VPN EVPN. Okay, but you can see that in my example, it is working perfectly. Show BGP L2 VPN EVPN, and I'm receiving the route type 5 from leaf 5, and also leaf 5 is receiving the route type 5 from leaf 3. Okay, so this is the only configuration that was done for leaf 5. So another example you can think of is that, let's say in this scenario, interface VLAN 10 is up on leaf 5. Okay, just give me one moment. So what we can do, let's assume that VLAN 10 is up on leaf 5. Now you can see that leaf 5 show BGP L2 VPN EVPN. Leaf 5 is receiving the 10 information from leaf 3, right? But you can see that if I do a show IP route, just one moment, show IP route VRF customer A, this time you can see that it is going to install its own route, right? Earlier it was the best route was from where exactly is that? Just here it is. So earlier the 10/8 was best via uh, 3.3.3, right? But now because the directly connected SVI is up, so it is going to install its own route only. Okay, so now what is going to happen in this situation? So in this situation, when the reverse traffic comes from host 6, so leaf 5 is going to receive this particular traffic, and now you can see that it has the route which is directly connected. In this situation, the exact endpoint IP is not there, right? Because as we know that host 1 is silent, but because now it has a direct route, so now the glean adjacency will be hit, and now it is going to generate an ARP request to find out where exactly 10.1.1.3 is. So it is going to send uh, an ARP request to find out the location or the MAC address against 10.1.3. So it will send it using the, like in our scenario, we are using the multicast as underlay. So using that, so that we already discussed in our packet flow also. So it is going to generate the ARP request. So host 1 is going to reply back to leaf 3. Leaf 3 is going to consume that information because the ARP request was generated from the source IP as Anycast gateway IP for VLAN 10 and the Anycast MAC address, which is also active at leaf 3 because they are using the same Anycast gateway for VLAN 10 and same Anycast MAC address. So that ARP reply will be consumed by leaf 3. Now leaf 3 will send a BGP VPN update for the host 1 IP and MAC, and then leaf 5's table or database will be updated. So this was all about route type 5. Okay. So I hope now you understand the value of route type 5 in case of inter-subnet communication, that even though we do not have the SVI is configured for that particular or the remote endpoint, still using the route type 5, a route or the main subnet was installed into the VRF table. So using that, a leaf can directly encapsulate the traffic to the remote leaf. Okay. So I hope you enjoy this particular video, and thanks for watching. See you in the next section.